Okay, welcome to a test review for Unit 4. I always do the Part 2 test first, that way we know how important it is. Shouldn't be a big surprise here. Part 2 is you are going to have to do an algebraic proof. And working through one is quite a lengthy process, and I would just refer you to the Class Connect recording that we had from Tuesday, November 3rd, where we did several in class. If you want to come and work on one in Life Help with me, that would be great, but that is what you are doing. Solving a problem and justifying each step with a property, an identity, whatever. It's an algebraic proof. Okay, Part 1 test next. Be able to state the members of a set given a specific set of parameters. For example, if you are given the criteria of a set that is multiples of 3 that are less than 19. So I've put my little set bars up here. We need multiples of 3. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. And I'm going to stop right there because if I multiply one more time, it will be more than 19. Don't forget, a multiple is also that number. A multiple can be that number times 1. All right, next up. Be able to select numbers that would make an inequality true. And this is just a revisit to our very favorite plug and chug. So let's start with number A here. We'll plug in 2 and see what happens. 11 plus 2x. All right, 11 plus 2x is less than or equal to 3x plus 1. We're going to insert 2 and see what happens. (11 plus 2 times 2 is 4. 3 times 2 is 6 minus 1. We have 15 is less than or equal to 5. That is suspicious. We are really way off. I'm going to go with, just because I'm curious, with a number right here. Let's try 0. The reason I try 0 is I know that anything multiplied that has an x in it will now be 0. So we can disregard that number and that number. Is 11 less than or equal to -1? No, I know it's not that one. So obviously we're going to have to do something larger. And it looks like because of the result for that one, it's going to need to be significantly larger. So I'm going to try this one. Could be wrong, but let's just see. 2 times 14 is 28. 3 times 14 is 42. 11 plus 28 is 39. 39 is indeed less than 41. Now, if this was a multiple select, I would go back and make sure that B is isn't an answer to, but where there was such a big discrepancy, I thought I needed to go big or stay home, and my gut was right. All right. Be able to identify which property is being used. You'll be given examples and you'll need to say if this is an example of the associative property, is it an example of the commutative property? And remember, what's the difference? The associative, the friends are on the bench in the same order. However, now they are associating with a new friend. Right now, 3 is hugging 2. Over here, 3 is hugging 5, but they are in the same order. Commutative property, remember those cows in the field, is when the numbers move around. Notice 2 went from beginning to last, 3 went from middle to beginning, 5 went to the middle. They moved around. They weren't just giving a hug to a new friend. All right. Distributive is when we have grandma bringing presents to two different grandchildren. We have to distribute the two to each member of the parentheses. Be able to recognize those properties in various applications. All right, you'll also need to be able to combine like terms to simplify an expression. The key to this is finding terms that have the same variable and the same exponent. These two may have the same variable, but their exponents do not match. They are not like terms. However, this one over here, both have an x, both have an exponent of 2. They are like terms, and they can be combined. And I'm going to rewrite them next to each other to kind of help us out. What do we have left? I kind of like to X them, so that way I know I've got them taken care of. Looks like we only have one single X term. I've taken care of that. What we have left now is just plain old numbers. Now, we could associate them together if we want to kind of keep us organized. X squared minus 3x squared. That's all by himself. There's nothing to simplify there. 3 plus 4 is 7, plus another 7 is 14. We have simplified that expression. Be able to apply the distributive property to be able to simplify expressions. Remember, grandma outside the house comes and brings a present to each grandkid. We'll rewrite that. Grandma, the 3, is going to come and visit her grandkid X, and she is going to come and visit her grandkid 3. 3 times x is 3x. 3 times 3 is 9. All right, we are not done simplifying. We've only applied the distributive property to those terms in the middle. We can now simplify by adding like terms together. Which terms are alike? We've got a regular number, and a regular number, and one rebel x. Let's add the like terms together. 7 minus 9 gives us a negative 2 plus the 12. Negative 2 plus 12 gives us 10. How did I do that last part? If I am 2 feet below the ocean and I go up 10 feet, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12 feet, 10, 11, 12, where am I going to be at? 10 feet above. That's how we get that. Okay. Be able to identify points on a number line, even if they are not nice, neat, whole numbers. If we have a number line like this, be able to plot where weird numbers like the absolute value of -3 is, or the square root of 2, or something weird like 4/5. So how do we do that? What is the absolute value of -3? Remember, absolute value is a distance. It is 3 units from 0. Once we drop it outside of those absolute value bars, it's a positive value. We would plot it right there. All right, what about the square root of 2? If you use your calculator to help you out, you would find out that it is 1.4. If you don't use your calculator to help you out, you can go, well, what's the square root of 4? It's 2. What's the square root of 1? It's 1. I know the square root of 2 is going to be somewhere in between 1 and 2, and square root of 2 is closer to the square root of 1 than it is to the square root of 4. So it's probably going to be a little bit closer to the 1. That gives you a way to eyeball it. 4/5 is almost 1. You can make little hash marks in there if you want to help you out, and then plot it right there. either way. Be able to plot numbers on a number line that are a little strange. Square roots, fractions, absolute values. All right. Be able to state the opposite of values. For example, if we are told that x is equal to -3, what would be the value of negative x? What is the opposite of x? So what is the opposite of -3? What's the opposite of -3? It's +3. Yes. +3 is the value of negative x in this example. Last one. Be able to simplify absolute value expressions such as this. If we are told the absolute value of -3.2, it would be 3.2. Remember, anything inside those absolute value bars, once you drop them, once you take them out, is going to be a positive number. Now the tricky thing is this example right here. We have a negative outside of it. So we have a -2. We'll drop the absolute value bars and it now becomes a positive value. So everything in there is now positive. It did not change this. That was outside the absolute value bars. So the absolute value of the negative of -2 is -2. Yes, be able to work through those, okay? If you have questions, please come to Live Help. And if you are ready to laugh at this meme, then you are ready to take this test. Again, questions, come to Live Help or send me a K-mail. And good luck.